Great day, ladies and gentlemen, and welcome to day 4 of...
Hey, you! Hey! Hey, you! Hey, you!
Okay, now it's quiet again. Welcome to day 4 of Labmas. Okay, one more time. Ladies and gentlemen, it is too noisy here. Let's go somewhere else. Okay, now we're quiet. Ladies and gentlemen, welcome to day 4 of... Now this is just getting frustrating. Where could I go? Where could I go? Oh. Okay. Ladies and gentlemen, welcome to day 4 of Labmas. It is quiet out here. And to celebrate today, ladies and gentlemen, we're going to be talking about sound. Now, we've already talked about sound in the beginning of the year, but today we have a really cool lab that I want to do that teaches us more about sound. So first, let's review sound with a vocabulary video.
Oh, hey, you hear that?
Yeah, I hear it.
Yeah, I think I can see it too.
Yeah, pretty much.
But if it's just a sound,
Right.
how can it move that water?
What, you don't know about sound?
Well, I guess not.
Let me just break it down for you a little bit, okay?
Tell me all about it.
Yeah, here we go. Listen up here.
Yeah, I'm listening to your sounds.
First off, sound is a type of energy. It needs a medium to move. Now, let me see. That could be solid, gas, or liquid. Yup, any state of matter is one sound can get with. Now, when something vibrates, it's cool. These teeny tiny particles called molecules get compressed, squeezed together real tight. And then what happens? They get rarefied or spread out, knocking other molecules around, creating a compression wave of sound. And if the sound wave hits something solid, like a window or a wall or a wallet, some of the energy gets absorbed, some transmitted through, but wait, there's more. Some energy could reflect and bounce back. That's an echo, yucko. Did y'all know that? Put your hand on your throat and hum. Pick up a guitar and strum. See that? Sound is vibration, and the other way around, vibration is sound. Sound. Put your hands together and clap. What? Or put your fingers together and snap. What? Sound is vibration, and the other way around, vibration is sound. Sound. Now, how can we describe a sound? Let's start by investigating sound waves and their parts, like amplitude. That's a sound wave's height. It determines the volume. Let's get it just right. If the volume's soft, then the amplitude's short. Make it tall, it'll get loud, like at a basketball court. The greater the amplitude, the louder the sound. It's the reason why we say, turn it up, turn it down. Now, the other part you need to see, the speed of the wave's vibration, the frequency. It's measured in hertz, which is a cycle per second. I'll tell you how it works. It determines the pitch, which can go all the way
Up high,
and then back
Down low.
So if a wave's vibration is
it
fast,
has a high pitch and frequency.
when it moves past. But if the vibration is slow,
The sound's pitch and frequency will be low.
yo, when we make sounds, waves abound. Speaking on the beat, our DJ lay down. Put your hand on a piano and play. And an organ will work the same way. Sound is vibration, and the other way around, vibration is sound. Now bang on a drum kit with a stick. Or when you whistle, feel it in your lips. Sound is vibration, and the other way around, vibration is sound.
Well, I get it now. I mean,
Right?
vibration is sound. Sound is vibration.
Yep, that's a good way to think about it.
I never thought of that before.
Well, you're welcome.
Okay.
That's right. This is the science of sound.
Sound.
Now, as you just learned from the video, or reviewed from the video, sound is vibrational energy. When things vibrate, when things move, when things are hitting together, they make what we call percussion or vibrational energy. And that vibrational energy transfers into sound energy. And ladies and gentlemen, we have parts of our body that actually receive this vibrational energy, and it's called our ears. We have different parts of the ear that actually vibrate as well, just in reaction to all that vibrational energy that's in the air that is created by that other thing. Now, we look at things that make energy. We know musical instruments, whether it's a guitar or whether it's a trumpet, and we also know we make energy. I'm making sound energy right now by talking and making vibrational energy because you're listening to me. And right now, if you're listening, your ears are vibrating at the sound of my voice. Now, what we're going to do today is do our day 4 Labmas activity that explores and investigates how we make sounds. And we're going to make something that makes some sound. Ladies and gentlemen, let's go head to the lab. So, ladies and gentlemen, we are now in the lab prepared for our experiment today, and our investigation is going to center around, can we create sound waves? Can we create something that is going to make sound? Now, as you remember, sound travels in waves. Now, I have the slinky right here, and if you notice, I'm going to touch this part. This part right here is going to represent the sound, and you're going to see if you can see the sound waves pass through. Did you see it? Let's go ahead in slow motion. If you noticed, where the sound comes from travels in waves and it moves along. So what we need to do is using movement, using vibration, and vibrational energy, we want to use something and make something that creates sound. So to do today's experiment, you're only going to need a few simple supplies. First things first, all you're going to need is a popsicle stick, a rubber band, a piece of string, probably about 2 to 3 feet long, a note card, and I also have playing cards because we're going to try it with a playing card today to see if it works, and eraser tops. All right. You will need a stapler for this as well. You can probably do it with tape, but for today we're going to be using a stapler. So let's go step by step in how to build our vibrational energy machine. All right, like I said, this experiment, super easy. It just takes a little bit of time. So the first thing you're going to do is you're going to take your popsicle stick and your card. And we're going to be using a Brain Busters card. And we have a picture here of, well, it looks like Niagara Falls. And it looks incredible, doesn't it? But we're going to use it for science today to see if it works. And what you're going to do is you're going to take your card and go to the center. And then you're going to place it in the center of your popsicle stick. And you're going to staple. Now, 2 staples should do the trick. And you want to be careful on the other side. If you notice, it does have the staples poking out. So definitely safety first. The next thing you're going to want to do is you're going to want to take your rubber band and place it between or on the popsicle stick. Now, this is a little tricky because the popsicle sticks are rounded, but if you notice, it sticks right to the popsicle stick. The next thing you do is you take your eraser top and you put one side in. That way the rubber band's not going to go flying off. All right? Then you're going to take your string and you're going to tie it around just one end of the popsicle stick. All right, so I now have it tied, and I'm going to take my other eraser top and put it on the other side of the popsicle stick. It's that easy. And if you look, it is all attached on this side, so nothing comes flying off. And now the fun part, the testing. So by itself, it's not making any noise. We have to add some energy to it. And by doing this, what we're going to do is create sound energy. But, well, how do we do that? I got my string. I got my device. I got it. I'm gonna remember what we did a few months ago when we talked about inertia and motion. And if you remember, we did an experiment where we spun a cup around and the cup was able to stay on the platform because of that motion. I wonder if we use that today to make some sound. So let's find out. So what I'm gonna do is I'm gonna give myself enough space. Now you don't do this around people because once again, the purpose of science, safety first and have fun. So what I'm gonna do is make sure no one's around me. Okay, and I'm gonna give myself enough space to spin it around. And I want you to listen carefully. Did you hear it? It sounded like a whistling sound, didn't it? By spinning it around, we were able to add our energy to it and create a vibrational sound with it. What was happening is the air was passing through the card and passing through the rubber band, and it was creating vibrational energy. Now I'm gonna do this one more time with a regular note card to see if we have a different sound. All right, so I have it now with just a regular old note card, and let's see if we get a different sound. Now I'm gonna have you make some predictions right now. Do you think it's gonna make a different sound? Now the paper is a little thinner than the original cards. I wonder what's gonna happen. Well, the only way to find out is to test it. So here we go. Make sure you're listening carefully. Wait a minute, that was a totally different sound. Between the two, well, here we go. Between the two cards had a different sound, and I'm wondering why. So I'd love to hear from you. Why did the two different cards make two different sounds when we swung them around? I can't wait to hear your answers. Now, ladies and gentlemen, I want to thank you for joining me today, and tomorrow, Day 5 of Labmas, and I cannot wait. You all did an incredible job today, and ladies and gentlemen, I can't wait to see each and every one of you tomorrow.